Hello and welcome to Shark Stories, presented by the Whaling Museum and Education Center, located in Cold Spring Harbor, New York. Today, we're going to learn what makes sharks excellent predators. We're going to discover some interesting facts about sharks and how they hunt, and we're going to do a really cool experiment to see why can they float in the water. Sharks are amazing. What do you think? Do you think sharks are fish or mammals? Sharks are not mammals. So if you said that, you're correct. Rather, they are a species of fish. Sharks have a skeleton that is entirely composed of cartilage and is equipped with leathery, tough, and scaleless skin. These skeletons differ greatly from those of bony fish. And so here you have a fish, and here you have an orca, which is a mammal, and which is a mammal, which is a whale. Sharks are amazing. The cartilage is durable, flexible, and has about half the amount of density as bones. And bone density is important for us because our thicker and stronger our bones, we're less likely to break them. As a result, with the sharks having cartilage, this helps to conserve energy and reduces the skeleton's weight. And what does cartilage feel like? So everybody wiggle your nose, okay, and wiggle your ears. That is cartilage. Sharks also lack a rib cage, which we have, which would result in its own weight crushing it if it were to be placed on land. Sharks do not have lungs like we do that breathe air. They breathe oxygen by passing water over their gills. Why are sharks so cool? Sharks, in some form or another, have been around for 450 million years. That's a really long time. However, the oldest known modern shark can be traced back to, just 195 million years ago, according to the Natural History Museum. I think that's still a long time ago. According to the Smithsonian, there are over 500 known shark species, though many are endangered or declining due to various factors like overfishing. Who knew? The whale shark is the largest fish in the ocean. And look at this mouth over here. It's a pretty big mouth. Whale sharks can grow to be 60 plus feet long. That's a solid 20 feet longer than a school bus. That's pretty big. The whale shark is known for its giant mouth and its distinct markings. It is believed that each whale shark's pattern is unique, like our human fingerprints. And there's that mouth again, this big mouth over here. So cool. Now, great white sharks are the largest predatory fish on the planet. The largest great white ever recorded, deep blue, weighed in at a staggering 2 tons or 4,000 pounds. That is huge. So, is that important? Yes. As an apex predators, sharks play an important role in the ecosystem by maintaining the species below them in the food chain and serving as an indicator for ocean health. They help remove the weak and the sick, as well as keeping the balance with competitors, helping to ensure species diversity. Shark senses. Now, one of the reasons that sharks are so successful predators is that they have super senses. So, like humans, we have sight, hearing, touch, smell, and taste. So the sharks have that also. But they have two other ones that we don't have. And their sight, hearing, and smell and taste is a little bit different than ours. The smell. Sharks have very well developed sense of smell. It has long been known that they can smell traces of blood from about 0.5 kilometers, which is about a third of a mile away. So just a tiny little bit of blood, they can smell it that far away. Now their sight. The shark's eyes are especially adapted to its murky, dark habitat. Unlike most other fish, the shark is able to dilate and contract its pupils to allow different amounts of light in, creating a clearer picture. Now we do that by going outside in the bright sunlight. Our pupils get tiny, they contract so we can see more, sharper in the bright light, but in the dark, they open nice and big so we can see more in the dark. Touch. Sharks have many nerve endings under their skin. Some also have barbels around their mouth that can be used to probe the sand for prey. And hearing. It is thought that sharks may have very well developed a sense of hearing. Their ears are comprised of small holes on the side of their head that leads directly to the inner ear. And taste. Unlike humans, the taste buds of sharks are situated throughout the mouth as opposed to just on its tongue. So we have it just on our tongue, they have it throughout their mouth. But another interesting fact about taste, we see in the movies, we see on TV that sharks go after people. Well, actually, sharks are really picky eaters. They'll take a bite, and if they don't like it, they just leave it and swim away. And they really don't like humans. They don't like humans' taste, so they'll just hopefully swim away. The sixth sense of a shark are called Electro Receptors, and they're called ambulae of Lorenzi. And these receptors are concentrated on the head of the shark, right here, okay, over here, and they can detect minute electrical pulses of their prey. So they can detect the heartbeat or the movement. They're really sensitive. We do not have this. And the seventh senses of a shark is the lateral line and is presented in most fish and use to sense tiny vibrations in the water. It's situated just under the skin, like you see in this diagram right here, along the snout, okay, and along either side of the body. And the lateral lines are canals that are filled with fluid. But they can feel, because of that, they can feel vibrations in the water and know their prey is close by. There are many types of sharks, like we said, and here is a few of them. We have a great white, the whale shark, the Greenland shark. So these are just a few of the sharks that are out there. So now is the time for your experiment. So what we need is two bottles of water, so two Poland Spring bottles, or either the small ones or the bigger ones. If you have the small ones, that is great. Cooking oil, it could be vegetable oil or canola oil, and water, and a large bin and some markers. Okay, so the experiment is what we're going to do with all that. What are we going to do with all that? We're going to see why sharks float in the water. So what do you think? Do you think sharks float, or do you think they sink? So let's find out. And why? How do sharks float in the water? To do this experiment, you need a large bin, and you're going to fill it with water. You can add blue food coloring to make it look like the ocean if you want. Then you're going to decorate your empty bottles. So here you see on the side here, I have two small water bottles. and just decorate them any color pattern you want. You can make a shark face on them. Then you're going to fill one all the way up to the top with oil and the other one all the way up the top with water. We did the experiment by filling it a little bit less than the top, so I'll show you what happens. Okay, so we're going to watch this video and see how it's done. Okay, so there I have my large bin, I have my bottles and my markers, I have water, and I have canola oil. Okay, so I'm going to take my 2 bottles and I'm just going to decorate. Okay, so you guys can be doing this too along with this video. And here we're just drawing a shark. So you can go ahead and take your markers. And we use permanent markers because they write nicely on the plastic. The other markers, it just comes right off. Very simple to make a shark. You make an arch and a little arch on the bottom, teeth. Okay, finish decorating it. And you don't have to make this kind of face. You can make anything you want on your bottle. Okay, this one's a little different that we're drawing. And as you notice, the 2 bottles are different sizes. That's okay too. But if you have the same size bottles, that works just as well. What we're going to do now is we are going to take the olive oil, well, I'm sorry, the canola oil and the water and fill the bottles. So you're going to fill 1 bottle with water. Okay, so we're going to fill 1 bottle with water. Okay, so you notice that that bottle's not filled all the way up the top. So we're going to try the experiment with it not filled all the way up to the top, and then we'll continue filling it up after. So now we're going to pour the canola oil in the measuring cup and put it in the other bottle. Okay. This is the one that you don't want to get all over. It's messy. Okay. And again, if you look at that bottle, it's not filled all the way to the top. Okay, so the next step we're going to do is we're going to see if they're buoyant. And basically what buoyancy means is if it floats. So there's the 2 bottles. One is going in. Okay. And that's the oil. Okay, so at this point, it looks kind of the same, right? What do you think? It kind of looks the same. So what we're going to do is add more oil and more water. So while we're doing that, buoyancy basically is being able to float. So if you guys ever have been to the beach with the salt water, you're able to float in the water with no problem. You just float. But if you ever go to fresh water, like a lake and swim in a lake, not so easy. So the salt in the water makes us buoyant. Okay, so we filled that bottle with water all the way to the top. We're going to put the canola oil in this bottle. Okay, put that cap on that. And we're going to put it back into the water again. This time it's all filled up. Okay, and the bin doesn't have to be big. It just has to fit your bottle. Okay, so that looks like it fell to the bottom. Okay, and that one is floating. Okay, so that one's at the bottom and that one's floating. When we touch that bottle, see, it doesn't move. That one keeps moving. Okay, so that was our experiment. Okay, so what did you observe? Which one floats? Which one sinks? I think we went over that. The one that um, floated was the one with the oil in it. Why do you think this happened? Remember, we only filled the bottle halfway up, then both floated. Why was that? Well, when we filled them halfway, the other half of the bottle wasn't empty. It was filled with air. Air is much less dense than water, and anything filled with air will float. Think about blowing up a beach ball or in a tube to use at the beach. Those things easily float on the surface of the water. When we filled the bottles up to the top, only one of them floated, the one filled with oil. That is because oil, like air, is less dense than water, and anything filled with oil will remain buoyant. So, why do sharks float? Sharks are buoyant. In other words, they don't sink, but they really could. Buoyancy is the ability to float in the water or other fluids. Sharks need to put effort into remaining buoyant. In fact, if they stop swimming, they will in fact sink. There are three ways that sharks use their bodies to float. Um, so this shark science activities covers one of them, and it's called the oily liver. And sharks rely on a pretty big oil-filled liver to help them stay buoyant in the water. Just like that bottle, so their liver is filled with a lot of oil to keep them buoyant. So I hope you enjoyed this presentation. I hope you learned a little bit about buoyancy and a little bit about the shark senses. Um, Thank you for joining me, and thank you from the Whaling Museum and Education Center. Thank you. Bye-bye.